Yeah, thank you. Thank you.
So our next presentation is paper ID 191, a novel federated learning architecture for robust multimodal mobility and crowd traffic co-management in smart cities. The authors are Nalini Singh Rajput, Ashutosh Mishra, and Navin Rajput.
Yes, okay. Thank you so much. Can I share my screen?
Sir, yeah.
Hello.
Yeah. Now you're audible, sir.
Oh, okay. So, can I share my screen?
Yes, sir, please.
Yeah, okay. A very good morning to everyone, and thank you very much for the opportunity to present our good work, latest work on federated learning based architecture. So, the title of our presentation is a novel federated learning architecture for robust multimodal mobility and crowd traffic co-management in smart cities. We are from IIT Varanasi, and we have one co-author, Nalini Singh Rajput from KIIT Kalinga Institute of Technology, Bhubaneswar. Then Dr. Ashutosh Mishra from BITS Pilani, Dubai. So in this work, basically, we focused on typical context that rapid urbanization and high density gatherings are significant features in smart cities, and there are different types of, as in the image we can see that different types of traffic flows are there, and each of the traffic segment is huge in itself. If we try to organize and manage the whole bunch of different types of groups, it is very difficult for the centralized AI to actually identify each of these. So, our conceptual approach was about the modular architecture and module based approach. So this is from where we got motivated to actually take up some distributed real time privacy preserving kind of intelligence, which will be able to initially streamline individual segment or group of people, pedestrians, two wheelers, three wheelers, four wheelers, bicyclists, and so on. So, in this way, in smart city, right now we are gathering all the visuals through a centralized the CCTV system. So all such streams are arriving at the central command and control center. So this is where we have simulated right now. So initially, you might have heard that we had Kumbh Mela incidents where many people got even they lost their lives, and this was very painful. Similarly, in during bomb blast or any kind of such activity, incidents, stadium exits are all of a sudden flooded with huge outrush, right? So, and it so happened that during the Kumbh Mela or the stadium event or other things, is still AI was enabled. Centralized command and control system was analyzing, viewing, and everything. However, the actuation signals which were getting received, they got delayed. They they took certain times, even sometimes they took 5 minutes to predict that some such kind of thing is going to happen. Typically, we have significant almost all the data from smart city Varanasi regarding the Kumbh Mela incident, and this is what we analyzed. So there is typical critical need of resilient multimodal intelligence. Multimodal means different types of groups of people who are moving. So in general, what we have seen, people are studying federated learning in silos. There is no unified system for traffic plus pedestrians plus IoT based intelligence. Nothing, no data is being gathered in this unified way. And certainly, the hierarchical federated learning aligned with ICCC governance integrated command and control system. I mean, we can say a lack of hierarchical federated learning aligned with smart city governance, right? So this is, and in fact, we are happy to share that we have filed a patent on this unified system for ICCC governance. So our work says, and this particular diagram, the federated the architecture has been even patented as well. We have filed for the patent. So there will be edge intelligence, there will be ICCCs. In fact, within states there are certain full-fledged integrated command and control systems. For example, in UP, there are about 17, right now 10 plus 7 are upcoming, 17 full-fledged ICCCs. So within these ICCCs, what we are doing, all the data is being gathered, then they are being processed for exclusive federated learning based models in different domains, different segments, and then the AI models that are developed, rather than exchanging the core data, we are exchanging the weights and biases. So what happens that there are many such groups of right now our work focuses on the mobility aspect. So group of people who are mobile in different carriers, we organized and trained models exclusively efficient on exclusive type of mobility, the mobile people, and then we federated this to create another segment. For example, within a city, so even the horizontal type of learning is within certain different mohallas and areas. So we created simulated different kinds of models. Then the weights and biases were exchanged, and then accordingly the central supervisor model was created. So in this way, multimodal integration is being done, vehicles, crowds, IoT, and then we have several 3 layers of validation, that is failures, data set, digital twin. So digital twin is also being has been attempted, and this is at the stage of being verified. So significant gains in accuracy like latency. In the Kumbh Mela, latency was the major issue. Then bandwidth, how much it consumes. Then resilience, whether it can still stay stable. So, as far as the theoretical background is concerned, much technology is already available about federated averaging and other things, so hierarchical aggregation. So, typically in this work, we typically focused on ICCC based central governmental control and administration. So, we have local, then we have regional, and then we have global model refinement cycle on this. Privacy and communication enhancement, obviously it will be there by the concept of federated learning, where the core data is not being shared. So of course that security is also available. Regarding the data sets and simulation setup, we used next generation simulation, US DOT program, which has produced high resolution naturalistic vehicle trajectory data set. So right now we have used it for this simulation. Then we have used simulation of urban mobility, SUMO. It is very popularly known, and it is an open source traffic plus mobility simulator and multimodal. So it does that. Then we have digital twin as well. And then crowd disaster reports were also referred to. regarding several case studies, we have studied the documented failures like Kumbh Mela and stadium exits, then data set driven simulations, then digital twin stress testing, so futuristic forecasting or the predictive forecasting was also attempted, and then holistic validation across various modalities were also tested. So in the result summary, the accuracy gains about the predictions were increased by 9 to 14%. The latency of response, which was the major cause of failure in Kumbh Mela, so it was reduced found to be reduced by 34%. Bandwidth consumption, because now we are not exchanging the raw data, so the bandwidth consumed was also reduced, and then fault tolerance improved by almost 14%. So these are the simulation result, and in fact we are working in collaboration with the Smart City Varanasi, where we are implementing it in real time under a project. Then certainly regarding the accuracy comparison, centralized AC, the congestion prediction accuracy was in centralized AI 81.4%, whereas in federated learning based approach it increased to 91.2%. Crowd density estimation accuracy, this also increased significantly. Initially in centralized AI it was 76.8, and in federated learning based approach it was found to be 89.5%. Stampede risk recall, so this also increased in centralized AI based system it was 72%, and in federated learning based approach it increased to 86%. Latency and bandwidth were also, so average decision latency, so it reduced, so the improvement was by minus 34%. I mean, it was increased, less time was taken in seconds. Similarly, bandwidth usage also got reduced. In centralized AI it was 12.5 GB per event, and in federated learning the simulation showed good enhancement, and it was only 4.8 GB per event. Ablation studies, certainly the security and other things can be considered, and we studied that part also. And we conclude that federated learning, the architecture wise, it is highly scalable, privacy preserving and resilient, and it is well aligned with ICCC governance hierarchy, consistent improvement over centralized AI. So we are actually working towards cross-city federated intelligence as well, 6G enabled low latency federated learning. We are also trying to compress the models and quantization advances that we will try, and in future, in our future work, we will also be including vision based plus sensory plus trajectory, different types of multimodal deep learning models. So that will be all. We acknowledge that the IPR rights belong to the corresponding author. The work is supported by NCC Lab, IIT BHU, and Ministry of Electronics and Information Technology, Government of India. Thank you. Now we are open for the questions.
Okay, it was a very nice presentation, and even looking at the experimental results, it looks like pretty promising results as well as the promising, I would say, directions for the future work as well.
Thank you.
Just one question I have here is about data set. Is the data set available publicly to access by any of the author, any of the reviewers, or any of the researchers working in this area?
Yes. No, originally the Kumbh data set, since it was a true stampede, so the data set is available to us through Smart City Varanasi administrators. We have signed MOU and clause of confidentiality with them. So that data set was made available to us. It is a huge data. However, to our academic collaborators, we can personally provide those data set after taking permission from them. So it is available.
Okay, great. Uh,
Yeah, thank you, sir, for such a nice presentation. So I have one question. So I just want to know the role of secure multi-party aggregation in this work. So that's the first thing, and the second is that, like, it seems that you integrated different technologies, and different like IoT is there, then the edge computing is there. So how complex thing, or what challenges you faced in the implementations of this work? So these two questions from my
You
side.
see, we have typically two specific simulation tools. Sumo is one very useful platform. So basically, as far as the software based simulation is concerned, it is not very difficult. So students, my students have done it actually. So that was possible. But certainly learning a new technology, especially at this complex level, is difficult. And most important is that the data set is generally getting generated in almost all the smart cities, and even in Dubai I observed that there are significant automations going on. So in general, data sets are available, modalities are available, so we can certainly segregate different types of data sets and create groups, and then through our traditional approach of developing federated models, so that is also possible.
Thank you, sir.
Yeah.
Thank you.
Okay, thank you very much for your presentation, sir.
Okay, thank you so much. Bye.